Okay, good evening, everyone. Let's start the meeting for today. Um, so, few days back, I went to a seminar, and it's for single medium. It's for single medium students. So, it was something like to do 25 practicals within 2 days. Okay, they were doing 25 practicals within 2 days. They were doing guest practicals, guest practicals. Therefore, I thought for English medium there's no such seminar, right? There's no such physical seminar for English medium students. So I thought to a English medium seminar live uh, and for free of charge. So this seminar we will be going through 25 guest practicals. Okay, we are not going to be going through all practicals because we don't have time for that. We only have 55-ish days for A-level exam. So I need to give you time to study as well. Therefore, we will be doing only 25 practicals. This is completely free and will be uploaded to YouTube and will happen live. Also, I had this question, how many hours will this take? Maximum 1 hour. Okay, we will be doing one practical within 1 hour. Okay. So take out your tubes. Let's start with the first practical. Usage of vernier calipers. Now, when we start the experiment, when we study about the experiment, we have to study certain things. What is the purpose of the experiment? Why are we doing this experiment? Okay. Then, what are the materials we need for this experiment to conduct this experiment? Thereafter, the theory related to the experiment. Then, the procedure, and we have to know some special points to do that to get an accurate reading in that practical. So, what is the purpose of this experiment? The purpose of this experiment is to understand the use of vernier caliper. Now, everyone can get a vernier caliper. It's a small but almost a cheap item to get. We can get that for a certain price, for a certain average price. But everyone doesn't know how to use a vernier caliper. After doing biology and maths, when you're going to your faculty, okay, we need to know, almost in our entire life, we will be using vernier calipers from now onward. So, to understand the use of a vernier caliper and to take precise measurements, we are learning doing this experiment. We are learning this experiment. So, what do we need? What are the materials do we need? First of all, a vernier caliper, and then the material you are going to be measuring. Okay. So here they have given block of wood, PVC tubing, and a solid sphere, and all the stuff you can measure using a vernier caliper. Now we have to. Next thing is we have to go through the theory of a theory related to this experiment. So, before we start experimenting with a vernier caliper, we have to know recordings will be provided till your exams. No need to worry about that. So we need to know the parts of a vernier caliper. I have given a vernier caliper here. Normally, vernier caliper is around 15 centimeters long. What is the maximum length of a vernier caliper? The maximum measurement you can take using vernier caliper is 15 centimeters. Then that, so yeah, and the main scale is located on this central axis. So we can, so we here we normally get a main scale. These two are called external jaws. These two are called internal jaws. Thereafter, this part, this part is called a sliding jaw. Now, if you see the tube I have given, there's a small well cap here, cap on the top. Can anyone say what is that cap for? What is the purpose of the cap, or what is the name of the cap? What is the name? What is the name of the cap over there? Let's make this interactive, okay? I can be just, yeah, it's called a locking screw. What is the purpose of that? After you take a, let's say if you keep an object here, when you remove it, the object twists. So when it twists, the reading will change slightly. To prevent that, when we take a reading using the external jaw, we lock the screw. Yeah, we lock the sliding jaw using locking screw and then take the measurement. Thereafter, so that's, I guess that's it, right? Yeah, what is this called? This is the depth bar. This is going to be the vernier scale. Okay. Next theory. Least count. How do you find the least count? In a vernier caliper, how do we find the least count? Normally, we have two equations for least count. What are the equations? We have 1 minus n over capital N. What is n over capital N here? N is going to be number of vernier divisions. And then capital N is going to be, sorry, N is going to be, simple N is going to be number of main scale division. And capital N is going to be number of vernier scale divisions. Times the smallest length, the length between two main scale divisions. This is one equation. This is one equation. This is a bit hard to work with. What is the other equation? Length of a main scale division divided by number of vernier scale divisions. This is the other equation. Okay. So we have these two equations to find the least count of this instrument. What is the in our school laboratories, in our basically within our A-level syllabus, what is the least count of a vernier caliper? Yes, it is going to be not 1 millimeter, not 1 millimeter. It is going to be yeah, 0.1 millimeter. Yes, it is going to be 0.1 millimeter. How do you get 0.1 millimeter? Let's just use this equation. So what is the normal distance between the main scale division in a vernier caliper? It's going to be 1 millimeter. Divided by how many vernier scale divisions do we get? We get 10 vernier scale divisions. This will give you 0.1 millimeter. It is always a must. It is always a must to write the units. Every single time, students forget that. Not because they don't know, because of stress. Thereafter, there are some other equations such as volume of a wooden block, volume of a material of a tube, volume of a solid sphere, and internal volume of a hollow cylinder. I guess all others are okay. How about volume of the material of a tube? Why is that? Why do we have that subtraction? Because normally a tube has the external diameter and an internal diameter. So what we are doing is, first of all, finding the volume of the tube, using the outer diameter, and then subtracting the volume of the hollow part. Thereby we get the volume of the material of the tube. I hope you are clear with that equation. If you are okay with my explanation up to now, please put a thumbs up. Okay, right? Am I fast? No, right? Okay. Then let's continue with the rest of the practical. Now we are heading to procedure of the practical. First of all, first and foremost, the first ever step you do with the vernier caliper. What did you do? What did we do now? Before taking any reading using vernier caliper, what do we do? We have to first note down the, find the least count and note down the least count of this, vernier caliper. Now I have taken this as 0.1 millimeter, but there are some vernier calipers which goes up to, I guess, 0.05 millimeters. That's the smallest you can ever get. Smallest vernier caliper you can ever get. 0.01 doesn't exist. We can go up to 0.05 millimeters in vernier caliper. So first of all, we are finding the least count. Second, we are checking the zero error. So there are two types of zero error, as you can see in the PDF. Positive zero error and negative zero error. What is positive zero error? When the zero mark of the vernier caliper, vernier scale lies on the right side. That means if this zero mark, this is how main scale comes in. One second. This is how we get a main scale. Okay. If the vernier scale 0 is past the main scale 0, then it is a positive zero error. Okay, right? Then how do we calculate positive zero error? We just find the coinciding point, coinciding vernier scale division, and then multiply that by the least count, and you will get the zero error. Then the second type is negative zero error. What is a negative zero error? When vernier scale 0 is on the left side, of the main scale, it is a negative zero error. Then how do we find the negative zero error? We find the negative zero error by, first of all, we have to find the coinciding division. Let's say the coinciding division is here. Coinciding division is 7. Coinciding division is 7. Then, if the coinciding division is 7, we have to subtract that number from 10. Not from 10, from number of vernier scale division, and then multiply by the least count. This is going to be number of vernier scale divisions, okay? And then multiply by the least count. Then you will get a negative zero error. Negative zero error, you can, if they ask for negative zero error, you can directly write what? 0.3 millimeters. But if they ask for zero error and the answer, the vernier scale is on the left side of the main scale, then you have to write negative 0.3 millimeters. Okay, right? If they are asking for zero error, this is going to be negative 0.3 millimeters. If they ask for negative zero error, then it's going to be 0.3 millimeters. Yeah. So when you are taking the zero error, then with the positive zero error, you will get the positive mark, and with the negative zero error, you will get the negative mark. So the direct thing you have to do is to get the correct reading, you have to subtract the zero error from the actual reading, and then you will get the negative sorry, you will get the correct accurate reading. I hope you are clear with zero errors. If you are clear with zero errors, please put a thumbs up. Shape. Next. Now we have figured out the zero error. Let's say first step we have figured out the release count. Second step we have figured out the zero error. Let's say 0.2 millimeters. Now we are going to do the actual measurement. When you are doing the actual measurement, what is the now? Yeah. Why do we use the external jaws? Just give some examples in the chat. For what purpose do we use the external jaws? To measure what object? Yeah, outer diameter. Measure the not the internal diameter, outer diameter of a yeah, outer diameter is correct. Otherwise, can we only use the external jaw to find the outer diameter? Height, width, length. What else? There's one more thing we are missing. One more thing I'm missing. It's in the tube as well. No, I don't know whether it is at the tube. No, you can say there's one more thing. There's one more thing we can measure. A spherical ball. In a spherical ball, yes, it is a bit hard, but still you can find the, let's say, diameter of a spherical ball using external jaws. Okay, ne? Yes, diameter of a sphere. What do you use internal jaws for? What do we use internal jaws for? To find the internal diameter of a cylinder. Yeah, that is fine. What else? Why do we use the depth bar for? There's only one reason to use depth bar. To measure the depth of what? Measure the depth of what? Of a hollow cylinder. Yes, they are there, but you have to keep in mind, you can only measure the depth of a hollow cylinder. Why? Because at the end of the day, when you're finding depth, this corner should hit a bottom. So you can't just find the depth of a pipe or anything. There should be a bottom to it. So only we can use this to only find depth of a hollow cylinder. That is a key thing to remember. So then how do we take a reading? How do we take a reading? It's a small thing. First of all, we take the corresponding main scale division or main scale length. We have to find the we have to find the main scale reading. We have to first read the main scale reading. Thereafter, how do you find the main scale reading? You have to find the main scale division which is just before the vernier scale 0. And let's just say this is we are talking about millimeters, this is 26 millimeters. Okay, so we are taking main scale reading as 26 millimeters. Why? Because it is the main scale division just before the vernier scale 0. Then we have to scan from left to right and find the coinciding vernier scale division. We have to find this coinciding vernier scale division and multiply by least count. Then we will get the reading for that measurement. Yeah. So the what do you call it? Equation for reading is given in the tutor as well. Now that's it for procedure. There's nothing else to do in a vernier caliper. Vernier caliper is all about measurements. This is the simplest thing, and the only practical that hasn't come for a long time. Measuring instruments, we haven't got a question for a long time. Okay, we have got made this thing, a micrometer screw gauge in 2024 something. Otherwise, vernier caliper came in 2014. That's why I'm starting with vernier caliper. And also, this is the first ever practical you're gonna ever do in your practical lab. So, if you are okay, if my explanations are okay with the procedure, please put a reactions. Okay. Reactions Madine. Madine. Hari. Okay. Then we'll move to special points regarding to vernier caliper. Whenever you are taking a measurement from a vernier caliper, what should we do? First of all, let's just say we are taking the measurement, no, diameter of this marker. Yes. Yeah, before I talk about special points, I'll explain that as well. We have 41 practicals. 41 or 42. We have 41 practicals, I guess. Yeah, we have 41 practicals. Out of them, 5 is removed by the government itself. And then we have electronics 4. We have 4 electronics experiments. Those experiments, the reason they don't give it to the exam is all the schools doesn't have the capacity to do this experiment. But instead of these 4, they can put some electronics theory questions into structure paper. Just for like 2 or 3 marks, nothing too much. Okay, they put like 2 or 3 marks for 2 or 3 marks of electronics theory question. I mean, you can just implement it using theory for uh, our exam paper. Then we have 41 minus 9 is equal to 32. Out of them, there are certain questions which have been coming again and again. The prism question has come for 2024 paper and 2025 paper. Now prism එක එන්නේ. එහෙම අයින් කරන්න පුළුවන්. ප්‍රශ්න චුට්ටක් අයින් කරන්න පුළුවන්. Otherwise, there are also yeah, we will be doing that as well. So, what is the matter equation? Properties of matter equation come under SN. We are just going to structure questions. Anyhow, so we can if we remove 7 questions like 7 practicals that not rarely come, that have been often been in the paper and rarely come and all those stuff. Yeah, left with 25. This 25 is more than enough to write your A-level exam paper. Okay, that's why this is 25 days, 25 practicals. If not, I won't be doing 25 days. I can do all 41 days. But then there's also another reason. You have 54 days left. After that, I'm doing classes 41 days. Then I get many years. 13 days. Within 13 days, how am I going to revise? Yeah, we will be doing that as well. We will be doing, let's say, I guess, except for electronics, all other lessons, there will be a practical. Electronics, electrostatics, you get creative questions in that I can't help. You just have to figure it out at that time because those are creative questions. Even we don't know whether you will get a question like that. So that's it. If you have any doubts, keep it, put it in the chat. I'll clear it after the meeting. Okay. So now let's go through the special points we have to consider when working with a vernier caliper. First of all, let's just say we are taking the diameter of this marker, of this red marker. Now, I don't know whether you can see. Whatever it is, the diameter over here is somewhat different from here. Diameter over here is somewhat different from here. Why? It is actually a cylinder. It is a perfect cylinder. But at certain places, because the ink, the what do you call, the sticker has gone, the what do you call, the diameter has changed. So if you take one measurement, will it be okay? Will it be okay or not? If yeah, we can't take one measurement. Therefore, we will be taking 3 or 4 measurements and finding the mean value of that of the diameter. This will reduce the random error occurring when measuring an object. Now, anyhow, diameter when you are measuring from here to here, the difference is going to be somewhat like 0.5 millimeter maximum, a difference of 0.5 millimeters. So this will reduce the random error because of the 0.5 millimeters. That's it. That is why we take average of 3 or 4 readings. Next thing. Now I said that's zero error. That's always if it is not a vernier caliper straight out of a box from a shop, that will be zero error. That is a must. Why does zero error happen? Why can you say like what is the actual reason, mechanical reason for zero errors to occur in a vernier caliper? All other instruments have different reasons. We just think about vernier calipers now. One reason is rust. Rust is what? Rust will, we can say vernier caliper will rust, and it doesn't matter if it rust here, ඒක වැඩක් නෑ. There's a rust rust formation here. It doesn't matter, we can still do the experiment. We can still take the reading. When it rusts, mainly these when you are using these objects, the coating at this point will wear off. Therefore, rust will form in the external jaws. Then when you close it, you are closing it with the rust. Therefore, there will be zero error. Number one. Okay, that happens when you are not using it for a long time. If you are using it very often, what will happen? Yes, there will be wear and tear. Then the external jaw will dig into themselves and create a negative zero error. So those are the 2 reasons. Also another thing, I didn't want to include in the video because it doesn't exactly matter. They haven't asked that. When you're taking zero error, what between which we have external jaws, internal jaws, and depth bar. What I find in the zero error for? What is the when for which part of the vernier caliper zero error is valid for? We cannot see internal jaws because yeah, when you close the vernier caliper, which one comes into contact? Internal jaws will never come into contact. They are separated by a small gap. Like this is one internal jaw, the other internal jaw is like this. They can slide side by side. So we can only measure it for external jaws. It is not even valid for depth bar, that is a normal thing. It is only valid for external jaws. So that is it about formation of zero error. Next thing, to take an accurate measurement with any instrument, we have to maintain a certain rule. The measurement should be greater than the... No, you can't say like that. The measurement should be taken such that the percentage error should be less than 1%. Okay? So percentage error, what is the equation for percentage error? Percentage error. percentage error, we have least count over reading times 100%. This is the normal reading. So we said it should be less than 1%. Then we can find the reading we need in order to take accurate measurement using vernier caliper. So 1% is equals to, what is the least count? Least count 0.1 millimeters divided by reading. Let's make it R. I'm going to take times 100 over here. Okay. Now, if we cross multiply, we get 1. We don't get 1. Yeah, we get 1 millimeter. You see 1 millimeter. Sorry, 10 millimeters or 1 centimeter. Yes, zero error will only be valid for the external door measurements. Because whatever you do, if you are taking the internal measurement, you cannot you cannot make the internal doors correct. Okay, you can make the external doors correct. You cannot make the internal doors correct. Therefore, zero error is not valid for internal doors. Now that yes. So the what we call reading should be greater than 1 centimeter in order to take a measurement in a vernier caliper. And the reading should be, let's also I'll also ask this question. The reading should be less than what amount in order to take the measurement? We can say it is greater than a certain amount, and we can say it is greater than, if it is greater than 1 centimeter, we can take an accurate reading. If it is less than what amount, can we take a reading in this? 10 will. We have 10 centimeter vernier calipers and 15 centimeter vernier calipers as well. We will always going with 15 centimeters, okay? Yeah, we will going with 15 centimeters. Because you can find a 15 centimeter vernier caliper. It is easy to find a 15 centimeter vernier caliper. 10 is hurry, but yeah, mostly 15 centimeters. Because there's meme like this, okay? If they ask, we have a 12 centimeter, okay, the reading is, the reading of object is somewhat close to 12 centimeters. What are you going to use? Meter ruler or a vernier caliper? Which one are you going to answer? We have a measurement close to 12 centimeters. Then what instrument are we going to use? Meter ruler or a vernier caliper? Yes, we use it. The answer will be in a marking tape vernier caliper. They won't choose main scale, sorry, meter ruler. Anything above 15 centimeters, they will take the 15 or 14 centimeters also, somewhat close to 14 centimeters. We can take the meter ruler. If it is close like, if it's like 12 centimeters or something, we have to use a vernier caliper to find the reading. I said about the least accurate measurement, maximum measurement, yes. Also, when using meter ruler, there's a story where our eye level should be straight or aligned with the reading we are going to take. What is the reason for that? In order to prevent, yes, human error, we call it actually, we properly, can someone else tell the actual proper, yes, to prevent the parallax error. In a vernier caliper, do we have parallax error? In a vernier caliper, do we have parallax error? Yes or no? We have, in a vernier caliper, we do have parallax error. Therefore, we are working with 0.1 millimeter. And then the thickness between the difference between the vernier scale and the main scale, like the thickness, will be around 1.1, 0.2 millimeters as well. So we have to make sure we are getting the parallax error as the no can have. Parallax error hadn't been vernier caliper. Make it one. This is the main scale. Okay. Name the vernier scale. මෙතන බලනකොට I mean your eyesight should be straight above the vernier scale. It should be straight above the vernier division. That is impossible to do. It should be straight above the vernier scale. Then only we can take a accurate measurement. If it is somewhat now, if you are taking using vernier caliper like this, මේම angle එක බලනවා නම් there will be a parallax error. Okay? ඒකත් හිතන්න ඕන දෙයක්. මේකේනවා තව මේකත් එනවා. මේකෙත් එනවා default traveling microscope also. If you when you're doing the your 2026 mostly, are there any 2027 students? May raise your hand. 2027. We have a few. අවුලක් නැහැ. 2027 student, if you want, just go and check. චුට්ට angle එක බලවම vernier caliper එක එක division එකක් පව වෙනවා. You will the coinciding division will go by it will jump up by one division. ලොකු ගාණක් නෙමෙයි meter ruler එකේ යනවා 2-3 divisions විතර පනිනවා. vernier caliper එකේ එච්චර නෑ 1 division පනිනවා. Because why? In a vernier scale මේව තියෙනවනේ. We have mean scale. 0, 1, 2, 3, 4, 5. And then below this we have a vernier caliper, vernier scale. This is the main scale, this is the vernier. Minimum in next one, following meter. And what is the difference between these two? 0.05 millimeters වගේ නේද? පොඩි වෙනසක් තියෙන්නේ මේක මැද පොඩි වෙනසක් තියෙන්නේ. So මෙයා තව එකක් එකක් තියෙනවා. හරිද? මෙයා coincide වෙනවා කියලා කිව්වොත්. If you look at it at an angle, you can see that this one is coinciding. ඒක නිසා parallax එක මේකේ තියෙනවා. අපි වැඩිපුර කතා කරන්නේ අපි. Okay? The basic idea is your eye should be above the vernier scale. Okay? කතා කරන්නේ නැති වැඩිපුර කතා කරන්නේ නැති point එකක්. ඒක exam එකේ ඉච්චට අහන්නෙත් නැහැ. I'm just saying if they are talking about parallax error, vernier caliper and traveling microscope also include. Okay නේද? concept එකක් දාන්න බලමු. Okay නේද? ඔක්කොම නිදි. Everyone is sleeping then? හරි. අවුලක් නැහැ. What else? Also, vernier caliper cannot be used to measure what do you call soft objects. Soft objects can make a vernier caliper की बाजू में. Can you find this thing? Length, breadth, height? No, we cannot use. So we cannot use soft objects. Even erasers we can't use. හරිද? තව අර solid වගේ තියෙනවා but elasticity තියෙන object ඒවත් that. You cannot use any soft objects or object that alter with pressure to find length using a vernier caliper. So what do we normally use? Steel, wood or plastic items. Yes. Thereafter, fast we have time. Parts that move in a vernier caliper. Okay. In a vernier caliper, we have fixed parts and sliding parts. What are sliding parts? ඔක්කොම type කරලා දාන්න බලමු. එක්කෙනෙක්. I give you some time. ඔක්කොම type කරලා දාන්න බලමු chat එකේ. හතර කියලා කිව්වනේ. හතරම type කරලා දාන්න බලමු. I'm not checking the YouTube live. I'm sorry for that. I should have been checking the YouTube live. එක්කෙනෙක් දාන්න බලමු. one of the external wall copy paste करा दो मैंने copy paste करा दो copy paste करने के बाद yeah one of each was depth one vernier caliper මේකම ටයිප් කරනවා නේ හොඳයි so that's it for vernier caliper experiment වෙන දෙයක් නැහැ there's nothing else left in this experiment you can go write an exam vernier calipers නේ shall we discuss the 2002 paper thumbs up නෙමෙයි heart එකක් දාන්න බලන්න හරි 2002 paper figure shows a part of the main scale and vernier scale division of a certain vernier caliper when their respective zero marks coincide what is the length of a vernier scale division in millimeters බලලා කියන්න බලන්න we have what do you call 1 millimeter divisions because 1 centimeter is divided into 10 parts so we have 1 millimeter divisions vernier caliper එකක් මකන්න ඕනේ නෑනේ I guess we can only go through 2002 paper අවුලක් නෑනේ we go through that first question part A yeah part A first one then we are going to find the least count we have what is the main scale distance 1 millimeter distance between the length of the main scale division is 1 millimeter we are dividing it into 20 parts no that's not it we are having 0.05 millimeters here not 0.1 we are having 0.05 millimeters hence or otherwise determine the least count so this is going to be part 2 part 1 answer is going to be 1 millimeter okay I got away ahead of my time yeah no they are asking for what is the length of a vernier division in millimeters what is the length of a vernier division 1 minus 0.05 මේ මේකක් එන්නේ මොනේ අර 1 minus ඉන්නෝ n එක තියෙන්නේ මේක දාලා හොයන්න ඕන you will get 0.95 millimeters okay මෙතන ඇත්තටම පාවිච්චි කරන්නේ 1 minus ඉන්නෝ n මේක පාවිච්චි කරාම we are getting this answer okay according to the above figure what is the least distance of the vernier scale that has to be moved in order to make a vernier scale mark coincide with each other again ඒකට answer මොකක්ද let's say third point is coinciding the third division is coinciding 1 2 third division is coinciding to make the fourth division coincide we have to move it by least count 0.05 millimeter 0.05 millimeter we have to move it by the least count okay so that's it with the first part එක ලොකු ප්‍රශ්නයක් නෑ second part B we have been given a hollow cylinder and they are asking for the measurement of D1 DH1 D2 and H2 what do we use type it onto the text external jaw H1 also external මේකත් internal D2 internal H2 is there's one more thing we can say what measurement here නෑ මේක ඔක්කොම average ගන්න බලන්න අවුලක් නෑ මේක ඔක්කොම average ගන්න බලන්න there's another thing also මේක this is a thing that we don't actually think about when we are taking the measurement the depth bar should be parallel to the cylinder okay yeah the depth bar should be parallel to the cylinder ඒ කියන්නේ මෙයා cylinder නම් depth bar මේව ඉඳලා depth bar should be parallel to the cylinder inner wall. Okay, and it should basically it shouldn't have any what's the specific angle, because when you put an angle, we are adding a sin theta into it, sin theta or cos theta into it. So what a reading value, but you won't get the actual reading. Uh, Write down an expression for the volume V of the metal. ඒක මම ලියන්නම්. ඔයාලට ලියන්න බෑනේ. chat එක ලියන්න බෑනේ. chat එක ලියන්න බැරි වුණාට මොකද්ද? We have a group name. Write the equation in a paper and send a photo. Let's try some new things, okay? You don't do this in a normal class. Write the equation, take a photo and send it to the group. This is a free session. Next time පළවෙනි ඉන්න එක්කෙනාට මොහාරි දෙන්න පුළුවන්. Free session ඉන්න බෑ. Okay? ඉන්නවද කට්ටිය නියම දාන්න පුළුවන්ද? දාන්න පුළුවන් කට්ටිය put a thumbs up. ෆොටෝ එක ලියලා ෆොටෝ එක කරන් group එකට දාන්න. පුළුවන් නේ එක්කෙනෙක්ට පුළුවන්. එක්කෙනෙක්ට පුළුවන් නම් වැඩක් නෑ. එක්කෙනෙක්ට පුළුවන් නම් වැඩක් නෑ. අන්න හරි. මෙයා මේක දාන්න. WhatsApp group එකට දාන්න නැතුව Zoom chat එකට දාන්න. 5d1 squared divided by 2 h1 minus 5. Yeah, that is correct. So what we are going to do, first of all, to find the volume of the cylinder, we have to first of all take the outer volume and then subtract by the inner volume. What is going to be the outer volume? 5 r square ලියන්නේ. r square ලියන්න බෑනේ. d1 divided by 2 square h 5 r square h minus 5 inner එකේ volume එක. මේ මෙහෙම තියන්න පුළුවන් because you have one line. But I guess there was a year, not a year. There was another paper where they asked you to simplify. එතන මොකක්ද වෙන්නේ? 5 divided by 4 5 divided by 4 එළියට ගන්න පුළුවන් නේ. Then we are left with d1 squared h1 minus d2 squared h2. And 2 squared is 4, so we can take 2 out, 4 out and 5 out. And write this as is. මේව නිව්වත් මාස් දෙනවා කියලා දීලා තිබුණේ in that year. But there was another paper where they asked for this simplified answer. Okay, then we have 5 minutes more. We'll do the D part. I'll give 2014 as a homework. 2014, every one of you do the 2014 paper. 2014 paper and send it to this number. Okay. Send it to this number. I'll check and say whether it is correct or not. Podi දෙයක් නේ. මම කළා දැන් මම පෙන්න මේ I'll check and test. Okay. So let's do D1. D1 එකට මේක ඕනේ. මේක මතක දාමු. D first part. When D2 was measured using a vernier caliper mentioned above, the portion of the vernier scale obtained relative to the main scale is given below. What is the value of D2? What is the value of D2? How do we take? First of all, we have to find the main scale reading. What is the main scale reading? 16 millimeter. Okay. Then we have to find the coinciding vernier division. Which line is coinciding? Then make them ප්‍රශ්න. We can say, yeah, that is the 13th one. 13th one time 0.05. That is the answer. Then we will get 16, 29, 0.05 is 50, 50, 55. Okay, 16.65 millimeters is the final answer there. What is the fractional error? Now, this is millimeters, ne? So we have to find a fractional error. Fractional error is going to be fractional error is going to be 0.05 divided by 16.65. What do we do now? What can we do? We can take this name 5 over 1665 කියලා ගන්න පුළුවන්. හරිද? තව simplify කරන්න පුළුවන් නේද? මේකෙන් cut it by 5 නේ. Then what will happen? It will be 1 over 29, 29, 29. Okay, that's going to be the answer. Shall we check? 333 times 5. Yes, that is the answer. So, මෙතනින් අවතන්න පුළුවන්ද? Simplification is not expected. I didn't read that question. අවුලක් නැහැ. Nowadays they expect simplification. This is 2002 paper. 2002 there were so many other stuff to do rather than a simplification. Now we have a lot of simplification to do. That's the biggest evolution of A-level paper. We can current that. Then, yeah, it's close to finishing time, 9:50, 9:59. Yeah, I have done 1 hour. If you have any doubts, please put it in the chat. Otherwise, 2014 A-level is your homework. Do this paper and either check it with the marking scheme or send it to me. If you send it to me, I will fully mark කරන marks දීලා දෙන්න බෑ. මොකක් හරි error එකක් තියෙනවා නම් I can say it to you. Otherwise, it is yeah, we can do that. If you have any doubts, send it to me. Otherwise, please මේ number එකටම send me a comment or a feedback on how the session was today. Zoom එකට දැම්මත් කමක් නැහැ. Good night for everyone. Have a nice day. I'll be going through doubts from now on, right? I can